In this video, we are going to finish off topic 23, talking about congruent figures. So let's get started. All right, so two figures are congruent if you can map one figure onto another by either reflections or translations or rotations. Those all form congruent figures. And we know that congruent means that all sides and all angles are equal. So as we can see here, with from A to B, we would go over 2 units, and then down 2 units. And then same here, we would go over 2 units and down 2 units. So from A to B is the same. From B to C would be the same. And from A to C would be the same. Angle A and angle A prime are congruent. Angle B and angle B prime are congruent. Angle C and angle C prime would be congruent. So that is what it means to be congruent. They are equal. They're the same thing, just in a different spot, like we've been talking about. All right, describe a sequence of rigid motions that maps A, B, C onto A prime, B prime, and C prime. So I'm looking at these two figures, and what I'm noticing that is they are in all the points are in the same position. A is above B and C, B is to the left, and C is to the right. So that tells me there was no rotation taking place. And I also see there it wasn't flipped over. So this is going to be a translation, or in other words, a slide. So let's figure out how many units we went to translate. All right, so let's go from A to A prime. So we went over 1, 2, 3, 4, 5, just 5 units. And then we went down 1, 2, 3, 4, 5, 6, 7 units. So what that's going to mean, so we already said it's a translation because we can very clearly see it was just slid. And we went from X, Y, and we're going to map that. Since we went to the right 5, our rule would be to X plus 5. And since we went down 6, our rule would be Y minus 6. So that was our rigid motion. It was a translation by the rule of X plus 5, Y minus 6. And since it was a translation, these two figures are congruent. Side AB is the same length as side A prime and B prime. Side AC is the same as side A prime C prime. Angle A is the same as angle A prime. They are congruent. All right, given DEF maps onto D prime, E prime, and F prime, describe a sequence of rigid motions that maps it. Again, I'm looking here. It is E to the right, and then D is up and F is down for both of these. So that means there was no rotation. The points have not turned. This is also not a reflection. So this is another translation. Now let's see how we translated. From D, we went up 1, 2 units. Or sorry, we should do, and then we went over 1, 2, 3, 4, 5 units to the left. So if our X is 5 units to the left, that means our X, so we're going from X, Y. And then we took away 5 from the X, so our rule would be X minus 5. We went up 2, so our Y rule would be Y plus 2. That is our translation. All right, let's keep going. All right, we have another kind of translation here, given and describe a sequence of motions that maps A, B, C, D to A prime, B prime, C prime, D prime. So I'm looking here, and in my original figure, A and D are on top, and in my new figure, they're on the bottom. So this was not a translation. But what it does look like to me is a rotation. So our original point was for point A, was at 1, 4. And then A prime went to -1, -4. And since we moved from quadrant 1 and then we went through 2 and then to 3, this was a 180-degree rotation. 180-degree rotation. And remember, with 180, it doesn't matter if it was clockwise or counterclockwise, but these are still congruent figures. A and B, side AB would still be 2 units, side AD, 1, 2, 3, 4, 5 units. Angle A is congruent to angle A prime, and so on. All right, so as we've already talked about, angles, line segments, and parallel lines all still apply with a new figure. So here, it looks like triangle trapezoid ABCD maps onto trapezoid EFGH. So what this is going to mean is that side AB would be congruent to EF, side CD would be congruent to GH. So I want you guys to think about now, side BC would be congruent to what side on the new figure? I'm going to pause and you're going to think about that. 3, 2, 1. And hopefully you said that it would be congruent to FG. Oh, actually, it also says it down here. BC maps onto FG, so those two sides are congruent. Angle A and angle E are congruent. Angle B and angle F are congruent, and so on. All right, so now let's prove if these two figures are congruent. Is JAR congruent to LID? So let's look at side JA and LI. From JA, we go over 1, 2, 3, 4 units, and we go down, sorry, I'm going to do it like this. And we go down 1, 2, sorry, we just go down 1, 2 units. So we go over 4, down 2. Now let's look at side LI. We go over 4 and up 2. So JA and LI are congruent because we go, our X moves 4 and our Y moves 2. Now let's look at side AR and side ID. From AR, for JR, we go down 1, 2, 3, 4 units, and we go over 1 unit. So our X goes 1, our Y moves 4. Now let's look at side LI. 1, 2, 3, it does move 4. However, it goes up 2. So these are not congruent because sides JA and LI are not the same. Sides JR, and now let's look at LD. I'm sorry, it goes up 1, 2, 3, 4, over 1. Ignore what I said. So these two triangles are congruent. 2 of the sides are congruent, so that has to mean that the third side is congruent. And to do that, I looked at slope. All right, let's keep moving along. So this was probably some form of translation and then a rotation. All right, that is going to finish us off, and we will talk soon. All right, bye guys.